Hey class, I'm Erisa. I want to once again take you through mathematics online. This lesson is intended for students taking mathematics at advanced level. It is statistics and probability for advanced level learners. So ordinary level students, it's not your lesson. Today we want to talk about two or more events associated with the same experiment, and you want to know how do you illustrate two or more events, okay, associated with the same experiment. Suppose A and B are two events associated with the same experiment. We want to consider the outcomes described below. So the first one is going to be A union B. So in set language, the set that contains the outcomes that are in A or B or both is called the union of A and B, and it is written A union B. You have done this before in sets. We want to bring in the concept of probability in sets. It's just going to be the same thing. But you have to understand what we mean by union of two sets. Okay, so here we are considering two events A and B living in a sample space S. So the union is this shaded part here, okay? A union B, and we write this as A union B. It means, okay, it means A or B or both. That's the meaning of A union B, okay? For example, if you throw a die, you'll get the sample space 1, 2, 3, 4, 5, 6. That is if the die is ordinary. And you can look at the prime numbers from this sample space, okay? And let A be the event, okay? The score is a prime number. So the prime numbers are 2, 3, 5, okay? And then you can have, B to be the event. The score is even. So you have 2, 4, and 6, okay? Now, the union, what we call A union B, it will be 1, 2, 3. Oh, we don't have a 1, which is out of the two sets, so we don't have this. Let me increase on the size of my rubber. Okay, so the union will be the set which is having a 2, 3, 4, 5, and 6. It is that set that contains elements that are in A or in B or in both, okay? If an element is in both A and B, it is written once in the union. Don't write it two, no. 2 belongs to both A and B, so you write it once. So that set is what we have tried to illustrate to emphasize what you have learned in set theory. So let's move on and look at the intersection. So we are looking at the A intersection B. In set language, the set that contains the outcomes that are in both A and B is called the intersection of A and B, and is written A intersection B, okay? This is how we write it. It is A intersection B. So let's have our sample space S. We have picked two events from the same experiment. So we are having event A and event B. So if these events share something in common, then it is going to be written here in the shaded part. And this is what we are calling A intersection B. It means, okay, A and B, okay? What is in both A and B is what we write in the intersection. So this is set A and this is set B, living in a sample space S. So with this kind of knowledge, okay, we have known what we call a union and what we call the intersection. Why don't we talk about the probability rule for combined events. Okay, so next is the probability rule for combined events. All right, so what are we talking about here? Look at a sample space S having two events A and B. This is a sample space S. So we have here A intersection B. Okay. And the B is this other set. So this is set A and this is set B. Okay. So we see that if the outcomes in A is, let's write this down. Now, what we are trying to talk about to come up with the combined rule for the rule for combined events, okay? We are looking at number of A and the number of B. If we add the number of A to number of B, do we get number of the union? The answer is no, okay? If you look at number of A, it is going to be covered in the whole of this circle, okay? And then number of B. So if you get number of A, okay, you have already taken the whole of this circle. What you need to do is to add on this other part to get the union. But if you're going to add on the number of B, which is the whole of this, then you are counting the overlap twice, okay? You have to take I1 overlap to get the number of the union. Let's get the next page and see what we do about this. The task we are having is to get number of A union B, okay? Now the number of A union B, we want to take what is in here, okay? And that's number of A, okay? So to get the union, what we only need to do is to add on this other part, which we call B only, okay? So plus number of B only. If we can do that, then we shall have the number of A union B, okay? So how do we get it? The number of A union B is number of A, okay, plus number of B minus number of A intersection B, okay? If we are to get the number of B only, okay, B only, if we are to get this other part only, okay, then we need to get the whole of B, which is this, and then take away this other intersection. So we shall have B only, okay? So we can say that, okay, number of A, let me write it here so clearly. Number of A union B is number of A plus number of B minus number of A intersection B. So we are talking in terms of probabilities. What we are going to do, let's dividing through by number of the sample space. What do we get? We have number of A union B divided by number of the sample space will be equal to number of A, divide this by number of the sample space, plus number of B, divide this by number of the sample space, minus number of A intersection B, divide this by number of the sample space. Okay, now we define the probability as number of events over number of sample space. Okay, so the number of A union B divided by the number of the sample space, this is the probability of A union B. Let me highlight this by bringing something which is going to be useful for all of you. I can write something here. Okay. and say that the probability of A union B is the probability of A plus probability of B minus probability of A intersection B. Okay, this is the probability of A union B. This is the probability of A, this is the probability of B, and this is the probability of the intersection A union B. So this is very, very important in probability. It's the rule for combined events. These are events of the same experiment. Okay, the probability of the union is the probability of A plus probability of B minus the probability of A intersection B. This is very important. I'm repeating it once again. Highlight it in your notebook. Very, very important. It will play a very big role in probability. Most of our work that is coming ahead is going to be based on this. Very, very important. I have repeated this for you here, so it is something so important. Now, let's talk about other useful results. Relating to events A and B. Okay, we want to talk about other useful results relating to events A and B. So what are these results? Remember, we are talking about events of the same experiment. Okay, you have here the first, this is A and this is B. Okay, this is the overlap, which is the intersection. A, B, they are both from a sample space S. So the probability of A intersection B will be exactly the same as the probability of B intersection A. So the order of arrangement of the event is not so important. Okay, so you can write as this: the probability of A and B, the same thing as the probability of B and A. And in probability means the intersection. So what is the other useful result that we can talk about? Okay, the other useful result is this is A, okay, and this is set B. Let me begin with this for you to be able to understand what I'm talking about. Okay, this is set B. Let me begin with set B here. Okay, whatever is not in B, we say is outside B, and we write it as B complement. Okay, now we come and draw set A here to intersect B. This is now set A, okay, and this is set B. So in this region, we have A meeting the outside of B, okay? You can talk about that as A only, okay? So we can see that, oh, you know, this is the intersection here. Don't forget, this is A intersection B. So for to be able to get the probability of A, what you're gonna do, okay? There are two regions that are covered in A, or A is covering two regions. There is A intersection B, and then A only, probability of A intersection B complement. So the probability of A is the same as the probability of A intersection B plus the probability of A only. Okay, this is A only. For to be able to get the probability of A, get the intersection, add on A only. Okay, that's going to be the probability of A intersection B. C, we talk about probability of B. The same way we have looked at probability of A. Let's talk about B. This is a sample space S. Set A, set B. Okay, A, B. So this is the intersection, which we are calling B intersection A, or you can call it A intersection B. And this other region here is what we are calling B intersection A complement. That's now the outside, where the outside of A meets set B. So we can say that the probability of B is the probability of B intersection A plus probability of B intersection A complement. Okay, so the probability of this is the probability here. This is the probability of probability of B and A, and this is the probability. This part is the probability of B but not A. B but not A is equivalent, the same thing as saying B only. Okay, B but not A, the same thing as B only. So then D here, okay, the other useful result that we shall employ in our discussion of probability is this other result I'm going to talk about. This is A union B, okay? But now we are interested in the outside of the union. We want to see what happens outside here, okay? This is what we are calling, this other part is A intersection. That's where the outside of A intersects the outside of B. So if we are to write P of neither A nor B, okay, is the same thing as 1 minus probability of A or B, okay? So the probability of A complement intersection B complement is the same thing as the probability of A union B complement. But we know something about complementary events, but the probability of A union B complement, the same thing as 1 minus probability of A union B, okay? So we can write something and say that the probability, okay, the probability of A complement intersection B complement, okay, is equal to the probability of A union B complement, okay? And this result is very important. I've actually stated it before writing it down. This result is very important in probability. Let me try to write this way. Someone will not understand it. This is the complement, okay? This is what we call De Morgan's rule, okay? De Morgan's rule, okay? It is very important. The outside, the intersection, the same thing as outside the union, okay? Probability of neither A nor B, okay? Not in A and not in B is the same thing as not in the union. So same thing as 1 minus probability of A, okay, union B. Very, very important. So let me summarize for these results before we start employing the results in our discussion. We can actually summarize the result in a table, which we call the contingence table. These 4 results we have just discussed can be summarized in the table below. We call it the contingence table, okay? We have 2 results. We have A and A complement. Then we have B and B complement, okay? So this is A intersection B, and this is A intersection B. So here we have, okay, A intersection B complement, and this is A complement intersection B complement. So what do we do then with these results? Okay, so here we're gonna put this probability of B, this probability of B complement. Then here we can put probability of A, okay, and then this probability of A complement. So it becomes really very easy for us if we want any of these results. What do we do? Let's see. Okay, if you're gonna need the probability of A, just look in here. Okay, this will be the probability of A intersection B plus the probability of A intersection B complement. And if you want probability of A complement, then we come and look right here. Okay, how do we get the probability of A complement? This is the probability of A outside A intersecting B plus, okay, the probability of outside A and outside B. Okay, in simple terms, what this is teaching you is this other part. If you have two sets, this is set A and set B. Okay, now the whole of whatever is not in A is what I'm shading in blue. Okay, remember they are living in a sample space S, so whatever is not in A, oh no, this is a big mistake here. Okay, let me redo the drawings. So whatever is not in A is gonna be, okay, so if you want to, okay, what is outside, what I've tried to write in blue here, okay, that's A complement, and this is A. So the probability of A complement, when we look inside this sample space S, there are two areas to look at. Okay, there's this area here, which I can write as the probability of A. This is set B, remember. Okay, probability of B intersecting outside A. And then there's this other part outside here. This is A complement intersecting B complement. So plus the probability of A complement intersecting B complement. So this table is really very important. It can give you anything. If you want probability of B, you will check here. Okay, so probability of B is the probability of A intersection B plus probability of A prime outside A intersecting B. Okay, look at this other pattern, compare with this. They are different. Don't think that they're the same. So probability of B complement is the probability of A intersecting B complement plus probability of A complement intersecting B complement. Okay, so the contingent table can give us or can summarize for us this information, but it is important to understand from Venn diagrams. You'll never go off. Now, the next discussion, which is the next lesson coming ahead, we are going to see the application of these results, how is them in solving questions on probability. Ladies and gentlemen, this is ending here for now. Remember to subscribe and click on the notification bell. Also share these links with your friends. If I have a big following, that benefits me. So help me as I help you out.